Hello, my name is Easton Kim, and this is my submission for my individual project. So there are a lot of wires and it's a bit confusing, so I thought I'd break it down in this video. So first off, we've got the 5-volt and ground pin of the Arduino plugging directly into the power and ground pin of the circuit board. Next we have the 4-segment, 7-segment display, which is connected to the wider range of digital input pins ranging from around 3 to 11. Next we have the photoresistor, which is connected to the analog 2 pin of the Arduino and is also connected to the power and ground rails of the circuit board. And then we also have the relay. Now this relay is connected to the digital input pin 2 of the Arduino, as well as the power and ground pin of the circuit board. Now another thing to notice is that this relay is bridging an extension cord that has been cut in half and then modified with wire caps, with the ground pins of the being input into the relay. This will allow for the relay to control whether the circuit is complete or not using the signal inputs from the Arduino. And then finally, the extension cord is plugged into an extension module, and then as well as the other end being the lamp plugged into the other end of the extension cord. Now, lastly, we have the power supply, which is just a 9-volt battery. This will directly plug into the Arduino. Once plugged in, we'll get an on light from the Arduino. Now, when we take a laser pointer and shine it directly into this photoresistor, the photoresistor is going to input a value, or output a value, my bad, of around 10. And now this is detecting from light levels on a range from 0 to 1,000. So 0 being the brightest, and 1,000 being almost complete darkness. So in the code, I have it set so that when the laser pointer shines on the photoresistor and drops the value to around 10, or below 250, and I'll explain a little bit later why it's 250, it should turn on the lamp as well as the display. Oh, my bad. Had to turn the lamp on first. The lamp turns on, as well as the display will display the letters on, O and N, to symbolize that the system is turned on. Now, if the value again drops below 10 once again, it's going to turn off the lamp. Now, the reason I have set it to 250 is because obviously this is a very small target. It's really hard to hit, especially if I want it to be turning on a lamp from a distance, from laying in my bed, so to speak. So we came up with kind of a diffuser, which is just basically a red solo cup with a hole punched into it for the photoresistor, with a tissue draped over it to help diffuse the light. And this will just basically go on over top the photoresistor. And I do have an example of me using this from my bed, which I will show now. All right, so that was this kind of homemade diffuser in action. And the reason we had to set it to 250 for the photoresistor is because that while sitting in this cup, when the light is shown through the diffuser, the values only drop to below 250. So when the light is shown in here, even though it's a bigger target, the value is much increased. So that's why the code was set to 250 instead of something like below 100. And ambient, while sitting in the diffuser, actually, the ambient value actually changes to around 300. So it's a bit more precise when we use the diffuser, but it makes it a much bigger target. So in the end, ends up working. Well, that was my submission for the individual project.